In 3.3, we're going to be looking at finding methods for finding zeros of polynomials. So let's kind of look here. First thing I want to note is let's kind of discuss what a zero of a polynomial is. And just kind of reviewing from 3.1, remember when we're looking at degree and x-intercepts, that the degree of the polynomial dictates the number of zeros. Remember, x-intercepts is zeros, roots, solutions. These are all the same words. So if we kind of think back to what we've done before, say we're given a quadratic like that, and we need to find the zeros. We said equal to 0. We factored. This would be x and x. The back sign tells you they're going to be the same sign, this sign. So it's both negatives, and then 3 and 3. And so we can see here that if we set both these equal to 0, again, this goes all the way back to unit 1, we could find the zeros of this polynomial, or x-intercepts. It was a degree 2, and we got 2 zeros. And so again, look at this one. This always goes back to unit 1. You could factor an x out. This gives me x squared plus 4 equals 0. I have something times something to give me 0. So that means either x is 0 or x squared plus 4 is 0. Solve this out. I get negative 4, square root both sides. Now that we know complex number, x is equal to plus or minus 2i, I from the negative, 2 from the square root of 4. And so you can see I did degree 3, and I got 1, 2, 3 zeros. Look at this last one. With this one actually factors. The square root of x to the 4th would be x squared. What will multiply to give you 1, 1, and 1. It's the difference, so I could do plus and minus. This thing factors out, set equal to 0. Now I can solve. X squared plus 1 equals 0, so I get x squared equal to negative 1. Square root both sides, so x is equal to plus or minus 1. That negative gives you I. Solve this one. X squared minus 1 equals 0, so I get x squared equal to 1. Square root both sides, and you get x equal plus or minus 1. So again, degree 4 gives me 4 zeros. Now this page is not to teach you how to factor and solve, how to teach you to factor it out, because we've already done that in Unit 1. We kept doing it in Unit 2. We've done a little bit in Unit 3. But this is just to affirm that when you're looking at the degree, it also dictates at max how many x-intercepts, 3.1, but we can also call those zeros. And so that's what we're going to be doing in this lesson, is finding the zeros of a polynomial. So part 2, there's the rational zero theorem. And what it does is states the possibilities for how many zeros you may have. And so when we're doing this, we're going to consider the rational zero. Rational just means it can be written as a fraction, so we're not looking at i's or decimals. We're just looking at fractions, p over q. So p and q have no common factors other than 1. When we're talking about p and q, p is our constant term. That's the term at the very back of the polynomial. And q is the leading coefficient. We've already defined this word earlier. It is the large number that's attached to their highest exponent. So as we go through this, we're going to do this rational zero test to give us the possibilities of how many zeros. And then as we go further in the lesson, you're going to see how we can apply and find the actual zeros. So let's look at some examples, because maybe p's and q's already lost you. So this is going to be your p, and this coefficient is going to be your q. If you have it written in standard form of decreasing exponents, then you will notice that the p is at the back and the q is at the front, but not always true. Make sure you look for the constant and the leading coefficient. Now we are looking at factors here. I'm looking at the factors of 24 over the factors of 9. So my possibilities would be, what will factor? What was the multiple of 24? So I'd start with 1 itself. So 1 and 24. I'm going to consider the positive and negative options. 2 goes into it, so I do 2 and 12. And I kind of go from outside in to make sure I don't miss anything. 3 and 8. 4 and 6. 5 is the only number between 4 and 6, so I know I have all my factors. All over the factors of 9. So 1 and 9, and 3 and 3. So these are all my factors. So you divide all of them out. So I'm going to divide all the top numbers by 1, which gives me all the top numbers. Haven't lost sound, just writing them all out. Then I'm going to take all the top numbers and divide them by 3. So I get 1/3, 2/3, 3 over 3 is 1. I already have it listed. 4 over 3. 6 over 3, which is 2. I already listed it. 8 over 3. 12 over 3 is 4, and I already have it listed. And 24 over 3 is 8, and I already have it listed. Now I'm going to take all the top numbers and divide them by 9. So I get 1/9, 2/9, 3/9 is 1/3, and I already have it listed. 4/9, 6/9 is 2/3, and I already have it listed. 8/9, let's see, 12 over 9 reduces to 4 over 3, and then 24 over 9. And so this right here is my possibilities of zeros. Now the degree is 4, so only 4 of these are going to work, and one might work more, twice. But I just wanted to first, in these first example, talk about what are the possibilities of what it could be. And I can tell you that all my real zeros are going to be in here. This does not account for any imaginaries that you may have. So we're going to look at the next example. Again, we're looking for the possibilities. And so we're going to do our rational zero test. So we do P over Q, and we're looking at the factors. So that means P is my back number, so it'd be 1, over the factors of my front number, which there's a 1 there. So the factors would be plus or minus 1, plus or minus 1, so very limited on factors. Divide all those out, and the only options are plus or minus 1. So that means of the 3 zeros that are possible, the real ones are only going to be -1 and +1. Problems you may see in your homework as you go forward. List all the possible rational zeros of this function. So I'm going to do P over Q. So I'm doing 4 over 2, and again, I'm looking at the factors of these two numbers. I'm not going to consider it being a negative because I'm going to account for that with all the pluses and minuses. So again, I'm going to look at the factors of 4, which would be 1 and 4 and 2 and 2. So that's all my factors. What are the factors of 2? That's 1 and 2. So I divide all the top numbers by 1, and I get 1, 2, and 4. Divide all the top numbers by 2, and I get 1/2. 2 over 2, which is 1, and 4 over 2, which is 2. So this would be all the possibilities of zeros for this function. Now again, the degree is 4, so 4 of them are going to work as long as they're all real. So at the base level, you could have questions on the exam, or you could have questions on homework of finding the possible rational zeros. Now let's take this a little bit further. Let's look at part 3 and look at application of the rational zero test. So let's not just find the possibilities, but let's actually find what works out. So what I want to do is I want to find all the zeros of this function. So the first thing I'm going to do is I'm going to look for my possibilities. Almost like, when you're doing like a word search or a crossword puzzle sometimes, or vocabulary in high school or middle school, they give you a word bank. That's what your possibilities are. That's kind of like your word bank. Like your answer's got to be somewhere in there. Now we're not talking about the basic kind of word banks where all the words work. We're talking about this one that like you might have words that don't work. So these are our possibilities we're going to pull from. So here's your P and here's your Q. And so I'm going to think 3 over 2, and I'm thinking the factors of 3 over 2. So the factors of 3 are 1 and 3. The factors of 2 are 1 and 2, and then you divide all the top numbers by each of the bottom numbers. So 1 divided by 1 is 1. 3 divided by 1 is 3. And you notice that again, I don't consider positives and negatives. I just put the plus or minus with each of them. Then I do 3 over 1, 1 over 2, and then 3 over 2. So those are my possibilities, but my goal in solving this is to find all 3 zeros from the degree that will work. So we're going to use synthetic to funnel through these and see what works. So, if you're very systematic, start with 1. I started with -1. So -1 is going to be my K. I'm going to put my coefficients. 2, 3, -8, 3, and I'm going to do synthetic. Again, watch the 3.2 part 2 video for more help with the synthetic, or maybe to rehear it if it's been a couple of days since you've done that. Bring down the 2, multiply, add, multiply, add, multiply, add. That is not 0, so that means this is not a zero of the function. So -1's going to work. But doing synthetic, you can see I funneled through that possibility query quickly, so I'm just going to try another one. Let's try +1. Again, using the same coefficients. So I'm going to do synthetic pretty quickly here. Bring down the 2, multiply, add, multiply, add, multiply, add. Getting a 0 here means that this is a 0 of this function, so I found one of them. You notice I started with an x cubed, and now I have an x squared. So if I look at what I have remaining, I've factored off that x minus 1 by finding the 0 here. Again, going back to what we did with synthetic division in 3.2. Now, I can just factor this thing out. 2x and x, which is -1 and +3. Solve all these out. That one gives me 1. We did that from doing this up here. Solve this one out. This gives me 2x equal to 1. Divide by 2. Look, 1/2, which was listed right here. So if I had done 1/2 with synthetic, I also would have gotten a 0. Maybe you chose that route. And then x plus 3, which gives me -3. And again, look, that possibility was right there. So you may have tried one of those. Maybe you didn't go in order. That's fine. At the end of the day, the point is to find these zeros right here. Now let me show you what would have happened if you had done them in order. So say we already did 1. I'm just copying over what I did right here. So I did my synthetic. Got 0. You can work where you left off, working with possibilities. Again, possibilities are 3/2, which we have all those listed up here. So maybe you tried -3 next. You do synthetic on it. And again, notice we got a 0. So that might be a better approach for you, especially if you're still struggling with this factoring, because notice that was an x cubed, and now that's an x squared, and now that's an x. You could set 2x minus 1 equal to 0, and you can see you can get here. Or possibilities are 1/2, so let me try 1/2. And so I'm going to bring it down. This gives me 2, multiply, add. You can see we also get a 0. So you can see how the synthetic division helps you to kind of pare down your possibilities and see which zeros are going to be nice to work with that problem. So synthetic division, not only have we used it just to simply divide instead of long division, we did it to evaluate, we did it to break it down. Now we're doing it to find all those zeros. And before we continue on with that, we need to figure out some other information. So maybe we want to look at finding a polynomial. We found all those zeros. Now what if we have the zeros and we want to work our way back up? A couple of comments we want to make is, let's talk about conjugate pairs. The last time you saw this word conjugate, we're working with complex numbers, and we talked about its conjugate of a plus bi is a minus bi. That was on your Unit 2 exam. Well, what's interesting is when you're solving a polynomial, these numbers come in pairs. And so it's important to know that imaginary numbers come in pairs. You're not just going to have I. And you'll notice from the very first page of our notes, when we did get an imaginary twice, look, we got plus or minus 2i, plus or minus 1i. You can see those were coming in conjugate pairs. So I want to make that comment here because now I want to work a problem backwards. I want to start with the zeros and work my way back up to what the polynomial may be. So I'm going to start there. It says find a 4th degree polynomial with real coefficients that has -1, -1, and 3i as zeros. Okay, so that means my zeros are x equals -1, x equals -1, x equals 3i. Now wait, that has 3 zeros, and that said it was a 4th degree, so we're missing one. Well, this is where it comes into play. If I have positive I can make the assumption that I also have -3i and be correct in it. So what we're going to do with this is, instead of starting with a 4th degree polynomial, like here's a 3rd degree one, we started with this whole polynomial and we broke it down to these zeros down here. We're going to start with the zeros and work our way back up, turn them into factors, multiply them back together, and end up at this point. So I want to work that problem with you here. So here's my 4 zeros. I'm going to first get them all equal to 0. So I'm going to add the 1 over, add the 1 over, subtract that over, add that 1 over. So now I got them equal to 0. I'm going to go ahead and put them back into parentheses here, multiplying them back together. Now, when you get a lineup of these linear factors, the best bet is to multiply your imaginary together before you start pairing them with the other items. And so first thing I'm going to do is distribute that. So x times x gives me x squared. X times 3i is positive 3ix. Negative 3i times x gives me negative 3ix. Negative 3i plus 3i gives me negative 9i squared. So these cancel. Now remember, can't forget stuff we've done earlier in the class. Remember, I squared is equal to negative 1. So I'm going to plug that in here. Negative 1, negative 9 give me x squared plus 9. Now I'm going to multiply this side together, x plus 1 and x plus 1. So just FOIL, distribute, box method. Gives me x squared plus 1x plus 1x plus 1. Combine like terms, so it gives me x squared plus 2x plus 1. And now I'm going to multiply that piece times this x squared plus 9. So distribute. That gives me x to the 4th plus 9x squared. Distribute. Plus 2x cubed plus 18x. Distribute. Plus x squared plus 9. So putting all that together, I have x to the 4th. 9x squared and x squared give me 10x squared plus 2x cubed plus 18x plus 9. So this would be my final answer in solving out this problem. And again, we worked from the bottom up. We had our zeros. We set them equal to 0. We wrote them in parentheses. We multiplied the imaginary parts together. We multiplied the real parts together. And then we distributed those two pieces together. So now I have that 4th degree polynomial that has the zeros that we were given in the problem. Lastly, I'm going to do one more problem with all this and kind of put everything together that we've been doing with zeros and rational zero tests and etc. This is like the queen of all problems here. If you're running out of space on your notes, go ahead and switch to a new page. I want to write this function as a product of linear factors and list all its zeros. So I want to work all together now. This problem didn't say find the rational zeros and then go from there. So you've got to know, I got to break this down. So look at your P and your Q. So first step you want to do is your rational zero test so that you can figure out what your possibilities are and kind of funnel through those. So I'm going to do P over Q, and again, these are the factors of P and Q. So that would be the factors of 8 over the factors of 1. 1 will multiply to give you 8. That's 1 and 8. 2 and 4. All divided by 1. So your possibilities of your 5 zeros you're going to have are going to be 1, 2, 4, and 8. Once you do your rational zero test, you want to funnel through those possibilities and see what works. So maybe you try 2. My coefficients are 1. I don't have an x to the 4th, so I'm going to put a 0. 1 from the x cubed, 2 from the x squared, negative 12, and 8. Now I'm going to do synthetic, so I'm going to start bringing things down. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply. This is not going to give me 0. This gives me 32. This is not a 0. So that means this 2 is never going to work for this problem. So that wasn't a good guess of mine. Let me maybe try 1. Should have started with 1. Again, I'm going to try this again and see if I can get a 0 out of it. So I'm just doing synthetic, multiplying, adding, multiplying, adding, multiplying, adding. Broken record here. 1 times 4 is 4. Add, multiply, add. Oh, goodness, that gave me a 0. So that means I would have x minus 1 times, I started with an x to the 5th. This is now an x to the 4th. So x4 plus x cubed plus 2x squared plus 4x minus 8. So I've broken off one piece of it. So now I'm going to keep trying. If you notice, whatever I have left here, I'm going to reevaluate. I have 8 over 1. So that means these possibilities still stand. I'm not going to go back and try 2. If 2 didn't work the first time, it's not going to work now. But I know I could try other stuff. So maybe let's try negative 2. Now I'm going to work with what I have left. I'm not going to keep back going up to the original. So 1, 1, 2, 4, and negative 8. So I'm going to do synthetic. Bring the 1 down. Multiply, add, multiply, add, multiply, add, multiply, add, and thank goodness we got another 0. So that means now we have the x minus 1 and negative 2, so x plus 2. Let's see, we started as x to the 4th, so now I'm an x cubed minus x squared plus 4x minus 4. Okay, we've broken it down. We started with a 5th degree. Now we're at a 3rd degree. Now I'm showing you each step and reevaluating as we go because I want you to see and understand that when you reevaluate, now I'm looking at factors of 4 over 1. So when I go up to my possibilities, I'm not going to try 8. 8 is no longer a possibility for this. So when we're looking at this, I'm reevaluating here because when I do that 4 over 1, again, I'm not going to try 8. 1 worked, negative 2 worked. You know, actually, let's just kind of think about this. My only possibilities would be 1, 2, and 4. Just doing that P over Q test. So I'm going to try negative 1. And again, I'm working with what I have left over. 1, negative 1, 4, negative 4. I'm going to do my synthetic, bring the 1 down, multiply, add, multiply, add, multiply, add. That didn't work out. Okay, well, of my possibilities, I tried negative 1. Let me try 2 again. Surely it might work this time. Well, you do all that again. If it didn't work way up here, it's not going to work again. So, you know what? What am I talking about? I'm not going to try that again. Let's try positive 1 again. So I got 1, negative 1, 4, negative 4. I'm just doing quickly synthetic on what I had left. Bring down the 1, multiply, add. Don't forget when you get zeros along the way. Multiply, add, multiply, add. That gave me a 0. So that means that was a 0 of this. This was an x cubed, so now I'm left with an x squared. I'm going to go to a new page. You can see I'm kind of running out of room here. So let's see. I have my first 0 of x minus 1. My second, which was x plus 2. My last one was another x minus 1, and it gave me a result of x squared plus 4. I can factor this thing. X minus 1 is good. X plus 2 is good. X minus 1 is good. X plus 4 goes back to the very start of our page. That factors into 2i and negative 2i. So this would be my fully factored form. So my zeros would be 1, negative 2, 1, 2i, and negative 2i. So I got my 5 zeros of this function. Just make sure, this was a long problem. That's why I wanted to end with this. Problem said, write this as a product of linear factors and list all its zeros. So my final answer would be all my factors and my zeros. But again, that rational zero test helped me to see the possibilities, so I'm not just funneling through every answer I know trying to break this down. If you need additional help on this concept or in this section, please feel free to holler at me and I'll be happy to help you along the way.